That's it. And there's first attendant. Good morning. Right. Where are we? Another minute, maybe. Okay. Good morning, everybody. My name's Nigel Hedges. I'm here together with Rob Jewell, who's muted at the moment, but he is present. I can see him to deliver you a little update, or update perhaps, a little presentation on setting up basic setup of the DSX and the Certifiber Pro cable tester and fiber optical loss set, respectively. I've called it tips, tricks, and options, and certainly I hope you'll be able to pick up a couple of things that are of interest or of use to you. This presentation is aimed primarily at our installer and end user customers, and yeah, there are a couple of things that that are worth looking into. So, without further ado, let's get started. Presentation is being recorded, as are the questions and answers, and will be available for review after the event. If you have any questions, please bang them in the question and answer box, which you'll find at the bottom of your screen, and Rob will monitor them, and hopefully he and I will be able to answer all of them at the end of the presentation. So, when we think about setting up for testing, we need to get the correct results. There's no point in going out spending a lot of time and therefore some money on producing test results which are then not as we would wish them. And when I say as we would wish them, I mean, are they acceptable to everybody concerned? Are they acceptable to the end client? Are they what he signed up for? Are they acceptable to the warranty provider? If there's a warranty involved, are they acceptable to the system manufacturer? Do they, if you encounter any issues, do they reveal sufficient information for the cable system manufacturer to be able to look at them and make sense of them? Also, when we're setting up for testing, it's really important to ensure that we've done the necessary pre-checks. So, does the tester have current calibration? Do we have the correct test accessories to hand? And do we know exactly what we're supposed to be testing? And I'll come back to that in a second. But first, I want to take a moment to talk a little bit about calibration. Tester accuracy and calibration go hand in hand. Our industry specifies an accuracy requirement for each tester, and in order to ensure that that accuracy is maintained, the unit should be, irrespective whether it's our tester or somebody else's, should be calibrated in accordance with the manufacturer's instructions. I view calibration very much as a cornerstone of the circle of confidence, and the circle of confidence to me is very much, sorry, just a second. The circle of confidence is very much to do with the relationship between the client or the end customer, the client's consultant, if he exists, because it is his role to assess and agree on the accuracy of the test results, the warranty provider or the system manufacturer, because essentially it's his product which is being installed, and therefore he is the one who is offering the warranty, and therefore it's his money which is at risk. Then the system distributor or reseller, because he's the one who usually gets it in the neck from the installer when it doesn't happen. And last but not least, Fluke Networks is also there because it's our tester which is going to be in the mix for getting the test results right. So together with the installer, the client, the end customer, the consultants, the warranty provider, and the distributor, we all have a concern with the test results being correct, and therefore the accuracy and the calibration of the tester is key to what we're trying to achieve. When we talk about calibration, we look to a calibration service and a calibration certificate, which should include a clear indication of where the test certificate comes from, where the testing was done, and you can see not only is there a Tektronix and a Fluke logo at the top, but down the bottom we have Fluke Netherlands BV, happens to be where our service facility is. So the test certificate should clearly show its origin, it should clearly show the date of calibration, and it should show the date that the calibration is next due. And last but not least, on the front page, it should have an authorized signature from the metrology or the head of laboratory who is involved. Then we get to the detail of the test certificate, the calibration certificate, and we should be able to see down here that this particular certificate is of the found left type. That means that when the tester was received for calibration, it was tested, it was found to be within specification, and therefore we did not have to adjust it. So it came in spec, it goes out in spec, there is no change. The other thing which appears on the test certificate is an indication of the standards and test equipment that were used for the calibration itself. So down here right at the bottom, this is on page 2, you can see what was used, which set of verification artifacts was used, the serial number, and the date that they are valid until. So we have a lot of data relating to the performance of the calibration, and then when we look at the actual test result itself, we should see every measured parameter shown. So here we have the first page of this test report, and what you're looking at is a graph of performance against frequency. The orange line is the worst case allowable performance for, in this case, for a level 4 tester. And the blue line is the actual performance of this particular instrument. And this is a DSX 5000. And as you can see, for near-end crosstalk, this is common to differential near-end crosstalk, common mode return loss, and then also for return loss as standard, TCL, which is transverse convergence loss, insertion loss. Every parameter is within specification and comfortably so. And we even have a third page which includes far end crosstalk. Again, we're comfortably within spec. Loop resistance, which obviously doesn't have a graph because it's a DC measurement, and resistance imbalance or unbalance, all shown, all relevant, all important to the test results that we are trying to achieve. So if you have a calibration report which does not include all of this data, you really have to question the validity of the report. We see a number of so-called calibration reports which do not include near-end crosstalk, do not include return loss. And frankly, if you don't include those two parameters, which are the two which are most commonly likely to fail after wire map, if you don't include the calibration data on those two parameters, what is the point of using a calibration service like that? So once we're certain that we have the measured parameters all displayed and that the unit is in spec, we can move on to planning our testing. And one of the things we need to do is make sure that we have the preparation in place. And I created this installation testing setup worksheet together with a couple of my installer customers, to try to cover off the things that tend to get forgotten or tend not to be passed necessarily from project manager to the field engineers who are actually going to do the work. So we've got some basic data here like contract reference, customer name, site, when we expect to start testing. Useful to ensure that the tester is calibrated and is in calibration, and that it has a current version of firmware installed together with the date of that. Approximate number of links. Why would we include the approximate number of links? Well, because it's important to know, because it will determine how long it takes to complete the testing in the first instance. Secondly, it also determines whether or not we need to apply more than one tester or possibly more than one set of permanent link adapters. When we're testing twisted pair, which test regime are we following? Are we testing on behalf of the client? Are we testing on behalf of the client with a warranty? Or are we using our own in-house test procedure? If it's a client, who is the client contact? Is there a warranty being offered? If so, who is the warranty provider? And therefore, where is the warranty contact? And what is his telephone number? What is the warranty test spec required to be? This is all data that goes toward making sure we get the tester set up right. Because getting the tester set up wrong makes for messes, makes for lost time. Lost time is lost money. So we want to be certain that we've got something sensible going on. The cable type involved, Cat5e, 6, 6A, 7, 7A, and Cat8. Little note here that says Cat7 requires different permanent link and channel adapter. Well, it doesn't say and channel, but it requires different connectivity because Cat7 and Cat7A use Terra connectors or GG45, and we have to address those differently. The construction of the cable, is it unshielded, unshielded twisted pair, unshielded with a foil, foil with an unshielded cable, foiled foiled or shielded foil, twisted pair, and obviously we have all of those different types to be considered. Anything apart from UUTP is automatically going to switch on the shield integrity test, which is crucial. And obviously, if you're testing Cat8, you do require a DSX 8000, so you need to have that. If the cable is a named cable, so if, for instance, it's a Panduit cable or a Conscope cable or a Leviton cable, then it's worth having the name in there because the manufacturers will be very pleased to see that on the test reports. Useful to know the nominal velocity of propagation of the cable, which does vary quite a lot depending on cable construction. We see everything from about 67% to about 79% in terms of nominal velocity of propagation. That means the speed of the cable varies massively depending on how it's constructed. Then the test limit. Are we going to test to TIA, which is the category 5E66A? Are we going to test to ISO or EN, which are the class D, E, EA, and F and FA? Or are we going to test to something completely different? Or are we going to use an application test? If we're going to use an application test, what application are we testing for? So are we testing for 10 gigabit compliance, for instance? That's an option. Or gigabit compliance. Are we interested in power over Ethernet compliance? These are all things to be considered when we're talking about that. And then the test method itself, are we testing the permanent link? So patch panel outlet to telecoms outlet on the wall. Are we testing the channel? So the same thing, but including the patch cords. Are we testing the modular plug terminated link, which is patch panel connection at one end, RJ45 male plug at the other? Or are we testing an end-to-end link, which we typically only find in industrial Ethernet environments, but end-to-end links and modular plug terminated links need patch cord adapters. So once again, we are asking the question in advance, do we have the right accessories to test what we need to test? And then last but not least, we have the cable IDs. Is there a list in existence? Yes or no? If there is, where is it? What's the file location? And if not, then are we testing to a sequence? If we are, does the sequence start with what and what does it end with? So all of this data is stuff that it really helps us to have before we start fooling around with the tester itself. This is the top half of a page. The second half is the fiber variant. In this case, I've filled it in a little bit with some jokey stuff. So we've got a contract reference, we've got a customer, we've got a site, we've got a project manager, sort of. We've got 480 pairs to be tested. Important stuff. We only got one day to do the testing, which with 480 pairs is quite reasonable. When was the tester calibrated? What version of firmware are we running? What is the test regime? In this case, we're going to run a warranty test. Is the warranty being offered? Yes. Who's the warranty provider and who is the contact there? What is the test spec? What is the cable type? In this case, it's OM4. Cable trade name and the connector type. In this case is Sierra Charlie. Now, the important thing about Sierra Charlie, Foxtrot Charlie, Sierra Tango is that you need different input connectors for your fiber tester. And you need different test reference cords. So do we have these? Are they available? If they're not available, then you are going to have a very unhappy time when you get to site. So you need to be certain that they're there. Test limit that we're using is ISO. And we're testing for loss length. We're going to use the end-face inspection unit as well. And we're going to test bidirectionally. We're not using the OTDR in this particular case, but we do have 2 connections per leg and 2 splices per leg, which is pretty much typical, I guess. As far as the cable IDs are concerned, we don't have a list, which is good, but we do have a sequence start and a sequence end, so we can use those to set up the tester. Now, all of that data is really quite crucial, and I'm certain those of you who have loads of experience with this will be looking at it and going, yeah, all that stuff's obvious, and he forgot X or Y. I challenge you over the next 20 minutes or so to work out what the X and the Y are. What did I forget to put on this testing with setup worksheet, answers in the Q&A or in the chat. Rob will monitor it and he won't tell me what they are. So now that we know that we have that, all of that data, we can now move in the direction of setting the tester up. We can do this in one of two ways. The one that I'm not going to use today is the Linkware Live Cloud service. Those of you who attended previous webinars will know that there's quite a lot of capability in Linkware Live. I'm going to do it directly on the front panel of the tester. And just to make life exciting, I am going to go back to this page and I'm going to add the instrument page. Do that. You don't have to look at my ugly face all morning, and I can move this onto the page here. And with a bit of luck, Rob will tell me if you can't see the VNC viewer, the instrument display, which is on screen at the moment.
Okay, Nudge.
Thanks, Rob. So I'll move that in front of me instead of over there in the window. And we can now create our new project. So first thing I'm going to do is I'm going to change the project. I'm going to have a new project and it's going to be called Mary's Cakes, and it's going to have the contract number in there because it makes it easier to track what we are doing. So there we go. That is the very first thing. The operator is me. For the sake of this, we'll use smooth operator because that's what I am. And the test setup that we're going to use, obviously there are no results left. This is a new test. We're going to edit the standard test setup, which is on the page, and the cable type that we're going to be using. Let's have a look at that. Obviously, we have lots and lots and lots of cable types. Let's have a quick look at manufacturers. So, for example, we have cables from lots and lots of people. Black one, black. Hopefully you guys recognize most of these people, or at least some of them. I'm looking for Leviton, just because I can. And here are all of the Leviton cables which they have declared to us. Purely as a matter of interest, if you find yourself looking for a manufacturer-specific cable and it doesn't appear in the list, please first and foremost make sure that you have the correct manufacturer name, because some of them appear under different names. And second, please be aware that this list is compiled by the manufacturer and provided to us, and we add it as a service. We are not responsible for maintaining the list. That is the manufacturer's role. He does that kind of thing. So if it doesn't appear, our apologies, there needs to be some work done. So in this case, I'm going to go generic, and we're going to go for a Cat6A SFTP. No, we're not. We're going to go for an FUTP. So that's foiled on the outside, unshielded in the middle. And the nominal velocity of propagation defaults to 74% for this particular cable. The shield test defaults on. So we are automatically testing for the presence, continuity, and quality of the shield. The test limit that we're going to apply, we've got a lot of them. And in this particular case, we are going to test for class EA, ISO class EA, because it's a warranted job. And in this particular case, as you can see, we have options. We can test for the permanent link to connector, class EA, plus PoE, or plus all, or just the bog standard test. Now, plus PoE means we include the tests specifically required for Power over Ethernet compliance testing. The plus all means that we include all of the advanced parameters for cable quality, which have been defined as a result of the arrival of Cat 8. My default is always to test for plus PoE. What I would say is that if you find you are having issues with supplied cable, I would switch on plus all, because it gives the manufacturer and warranty provider of the cabling system the ability to look into as much detail as they possibly might need. So in this case, we're going to go plus PoE. Store plot data is always on, because we never don't store plot data. Couple of things, and here is an option. In the HD TDR and HD TDX, those are our diagnostic functions. So you have the ability to switch it on for for fail or star pass only, which is when you really need the diagnostics. You can opt to run it for all auto tests, which will add about 1.5 seconds to the test and save time, or you can opt to run it never. Running it never saves you no time at all, unless you get fails, in which case it saves you 1.5 seconds. If you have dodgy cable, I would select all auto tests, because then you can provide your cable manufacturer with a full set of test results, both pass and fail, and what the cable looks like all the way down. So in this case, we're going to leave it as fail and star pass only, because that makes a lot of sense. And the outlet configuration is T568B. B for Britain, A for America, and we're in Britain, so we're doing the T568B thing. So I can hit save, and fundamentally I am now ready to go testing. There's nothing else I need to add except for the cable IDs, and the cable IDs need a new ID set. So I can enter my first cable ID here, and because I'm anal about this, we start with C6A, then we go cab A colon panel 01 slash 01. And the last cable ID is going to be cab D, panel 05. So these are all Cat 6A test results. We have 4 cabinets. Each cabinet has 5 panels in it, and we have 24 ports per panel. If that seems unrealistic, then my apologies. Obviously, you can have as many cable ID lists as you like. So you could have a separate one for each cabinet if you needed to. It's entirely up to you. So once we've done that, we hit done. And I can have a quick review here. And here are the cable IDs, as you can see, going panel 1, 1 through 24. I can scroll up here, and then we get panel 2, and we go halfway. We get cab B, cab C, and cab D. So all of that data is there, and then we hit save. And here potentially is one more tip, and that is down the bottom here, you'll see there is something called Next ID 001. Next ID 001 is the default cable ID list which exists in every project. And since we don't want to use it, I'm going to delete it. And the tester is now forced to use the cable IDs that I gave it, which from my point of view is a damn good idea. Now, that is a copper test setup. It's taken me a sum total of 6 minutes and 40 seconds, including the fooling around time. But the important thing is that had I had my testing worksheet in front of me, it would have been quicker and easier, and I would have had very few decisions to make because all of the answers would have been on the sheet. We can do another one for the fiber setup. Let me move up a page and recover the VNC. There we go. So this is the fiber setup, so I can go new test. And in this case, we're going to change to the Certifiber Pro. And it's a quad unit. And it is a smart remote test, bidirectional. Yes, we're going to do bidirectional testing. The fiber type is OM4. Once again, I have lots of different options. I have manufacturer specific ones. I have generic ones, so we're going with the generic OM4. The test limit that we're going to apply is ISO. And in this case, ISO IEC 14763-3, the 2014 edition is the relevant one. The reference method, well, interestingly, ISO only allows you a one jumper reference. So we're doing a one jumper reference. Let me go back a page. The connector type is Sierra Charlie. And the number of connections and splices is 2 and 2 according to my page. So that's what we're allowing for. And we can hit done. While we're on this page, let me just show you, when it comes to test limits, we do have the option of vendor test limit. And the vendor test limit at the moment, the only vendor who has signed up to a custom test limit is CommScope. And those of you who are CommScope installers will find that we have Systemax Field Terminated and Systemax Instapatch options built into the tester. So we can go to Field Terminated, and we now have to specify how many SC or ST or LC connectors we have, how many splices, and the jumper reference. And we can configure a very specific test, which is 100% in accordance with Systemax, CommScope Systemax's published loss calculator. So the loss calculator that we used to have in an Excel spreadsheet, still do, and also exists as a tablet and mobile phone app, is now included in the tester exactly as CommScope specified it. So it works exactly the same way, and it is entirely reliable. We're not going to use that one though. I'm going to use this one. And 2 and 2, and we hit save. And what we now have in 98765062020 Mary's Cakes is we now have 2 test setups, one for the fiber, one for the copper. And what we need to add is a new ID set. And this is going to be called OM4. And I did say slash. Can't spell though, can I? Panel 01 slash Cav D, panel 6. Panel 6 and 48. Done. And in this case, these are fiber test results. And I am reminded that there's loss length testing to do, but there is also fiber inspection to do. So we use the same cable IDs for both ends. We can review the cable IDs. There's 1,152 of them, which is rather more than the 480 I said in the number of pairs. However, it is what it is. And we hit save. And we now have 2 cable ID sets. I quite like the idea of using the cable designation, so OM4, Cat6A, whatever, at the front end of the cable IDs, if you're allowed to, because it helps identify what type of test result you have. These are pointers, options. You do not have to use the cable ID set function, but if you do, the likelihood of getting incorrect cable IDs is much reduced. Obviously, if you have a lot of fails, then it does make life a little bit more exciting, but generally speaking, I would suggest that this is the best option to follow if you can. So all of that data is now in the project. I can go home on the tester, and here is our project ready to use. If we decide we're going to test the fiber first, then if we touch where it says the test setup on the page, we can choose the fiber setup first. If I do, the tester will complain that it doesn't have a fiber module fitted, so I won't do that. But we are fundamentally good to go. The only thing that is worth checking up at the top of the screen here is that the date and time are correct, which they pretty much are. And here we go to version information, and We are running version 6.5, the limits version is 7.5. And if we want to check the modules, the module calibration date, which is the bit we care about, is here. And we can see that my tester requires calibration, but then mine is a demo unit only. Obviously, yours needs calibration. Okay. So, as far as setting the tester up for copper and fiber testing is concerned, I suppose the one thing we ought to do is we ought to add one more test, and that is the end face inspection test. So if we go here, we go Fiber Inspector Pro, we say test type Fiber Inspector. Where the test limit is concerned, we have options. We can inspect and document only, which means we take a photo of the end face when we think it looks lovely and clean, and we include that in the test report, or we can apply the IEC 61300-3-35 edition 2, which is the current edition of the standard end face condition standard. For the purposes of this, I'm going to go document only. The end type is a single fiber. Obviously, we have the ability with this unit to also check multiple fibers. So we're going with the end fiber, and we say done, we say save, and we are ready to go. So there we go. Setting the tester up. I hope I haven't gone too fast, and I apologize that you can't see where I'm pushing, but it is very logical, one step at a time. The only thing I would say is when you change the cable type from Cat6A, which is the default in both the DSX 5000 and 8000 and in the 600, when you change the cable type, you must also change the test limit, because the test limit defaults to Cat6A as well. And if you're testing Cat5e cable to a Cat6A limit, you will get 100% fails. And I do get irregular calls from people who immediately ask me what's wrong with the tester because everything's failing. And fundamentally, the answer is you changed the cable type, but you did not change the test limit. So just be aware of that. One last thing that I wanted to show you while we're on the instrument is we were looking at some results. This is a set of test results from a webinar which I ran a couple of weeks ago. And what I wanted to show you specifically was this. This is the test reference chord verification. This is the part of the process after setting the reference when you're testing fiber. This is the part that confirms that the test reference chords are in adequate condition to carry out the test. And the important thing here is there are two important things. One of them is that the loss is extremely low, which is good because it means the end faces are in very good condition. The second is that there is a measured length. The measured length should be around 2 meters, and it indicates that I did install the second test chord before I hit the TRC verification button. If you do not install the second chord, then you will have no length measured, and your warranty provider will pick this up in about half a heartbeat and will reject your test results because you did not set the test reference chords up properly before you started. Right. So, ladies and gents, boys and girls, I'm not even sure that we have any ladies. I think that that is probably sufficient from a tips, tricks, and options point of view. And I thank you for attending. I thank you for staying awake. I am very happy to answer any questions that we may have.
We had one question, Nigel.
Yes.
Would you forward across to the attendees the copy of your copper and fiber Excel setup sheet? And I said that I answered the question saying that you'll send it to all attendees after the presentation.
£55 each, because I'm not cheap.
So that'll be winging its way across to all the attendees.
Yes, no problem at all. It is one sheet, and obviously you can add to it, adjust it as you see fit. Did anybody spot the bit that's not on the sheet?
Nobody answered.
Well, fair enough. Short answer is there was no POE option or plus all option on the sheet because I didn't get around to adding them last night when it was late. Okay, if there are no other questions, I'm happy to answer anything that comes up. I will say thank you all very much indeed for attending. Hang on, what have we got there? And yeah, I will thank you all very much indeed and say have a great rest of the week. It's Thursday, so there's only Friday to go. Take care, stay healthy, stay sane. Rob and I are doing our best to do both of those, and look forward to seeing you next time we have a webinar. All the very best. Thanks, guys. There we go, that's it.